dash x के पीछे क्या है? F of g of x. I have taken that song because you have to say in this problem what is the function behind g dash x. It is f of g of x. Why I named it as inside derivative out? It is f of g of x into g dash x. F of g of x. The inside function derivative lies outside. Wherever such a function you come across, it is very easy to write the derivative, and it is simply f of g of x dx, where small f of x integral is nothing but capital F of x. So you have to consider whenever f of g of x into g dash x integral as fx only. So then you can avoid the substitution if you see that. Let us go through that. So just go through this carefully. F of g of x, this is inside function, derivative outside. Then it is f of g of x dx, where integral of f of x dx is equal to capital F of x plus c. Let us see the problems, and these problems are very comfortable for you to write the answer. So first one is integral dx by 2 root x into 1 plus x. So write that 1 plus x simple like this. Write that 1 plus x like this, please. It is integral of dx divided by 1 plus root x whole square into derivative of root x. Just check it out. It is a direct problem. No need to write anything. No need to write any adjustment there. So it is straight away you can take it as integral 1 upon 1 plus x square, which is anti-differentiation formula directly. Integral 1 upon 1 plus x square is tan inverse x. Within one step you can write the answer. It is tan inverse root x plus c. Done. The first one. Coming to the next one. Cos x square into x dx. What is the derivative of x square? 2x. You have to make an adjustment here. Integral 1 by 2 cos x square into derivative of x square. Just see that. In place of x you have x square. In place of x you have x square. Let me correct it, please. In place of x you have x square. So it is integral of cos x square into, I am writing it as derivative of x square, which is 1 by 2 I wrote. So if you see that carefully, it is nothing but in place of x we have x square. That's it. So you have to consider that as integral cos x only. What is integral of cos x? Sin x. So half sin x square plus c. Done. Coming to the next one, please. It is integral of a power root x by root x. Just see that carefully. It is nothing but integral of a power root x into derivative of root x. What is derivative of root x? 1 by 2 root x, which is not there. So you'll get 1 by 2 extra. So write 2 here. It is just like this. Integral a power x dx. Standard formula, integral a power x dx. What is integral a power x dx? A power x by log a plus c. Done. Within one step we are writing this. Just see that carefully. Next one, e power m tan inverse x by 1 plus x square. See that? If you see the derivative of m tan inverse x, what is derivative of m tan inverse x? It is m by 1 plus x square. It is very much there. Of course, m is missing. Write 1 by m out. Consider this as e power x only. Consider that as e power x only. What is integral of e power x? E power x. So your answer is e power m tan inverse x plus c. Done. So this is inside derivative out. That is why I named it as inside derivative out. Just let us see the next problem here. Next one is e power sin square cos square x into sin 2x. E power cos square x into sine 2x. Just see that. If you see the power of e, it is cos square x. What is the derivative of cos square x? Minus 2 sine x cos x. Of course, minus is missing there. So write a minus out. No problem. It is integral of minus integral of e power cos square x into derivative of cos square x. Just check it out. Derivative of cos square x is 2 cos x into minus sin x. Minus is missing. That is why I wrote minus out. Now, straight away, take it as, minus in the standard format, integral e power x. E power x integral is e power x only. So your answer is minus e power cos square x plus c. It is done. It is done. Coming to the next one. If you see that carefully, it is also integral of e power x minus 1 by x. Write the derivative of x minus 1 by x, please. See that? What is the derivative of x minus 1 by x? 1 plus 1 by x squared, which is very much there. So it is again e power x form. In place of x, you have x minus 1 by x. So, what is the derivative of, what is the integral of e power x? E power x. So, your answer is e power x minus 1 by x plus c. Done. Next one. Integral of 3x squared divided by x power 6 plus 1. Integral 3x squared is there. And the denominator 1 upon x cube whole square plus 1 into derivative of x cube. What is derivative of x cube? 3x square. Straight problem. Derivative of x cube, 3x square. Now, x cube here. Consider it as x. It is integral of 1 upon 1 plus x square, which is nothing but tan inverse x cube plus c. Done. Next one. Integral of secant square x divided by root over tan square x plus 4. What is the derivative of tan x, secant square x? So it is integral of 1 upon root over tan square x plus 4 into derivative of tan x, please. What is derivative of tan x, secant square x? I wrote secant square x as derivative of tan x, which is nothing but integral 1 upon root over x square plus a square. Integral 1 upon root over x square plus a square. You can write it as sine h inverse x by a. But in JE level, you don't have hyperbolic functions and hyperbolic inverses. You have only logarithmic value, equivalent logarithmic value. So it is ln mod of x plus root over x square plus 4 plus c. That's it. All the 4 problems are done here. Let us see the next one now. Next one is, if you see 5 power x. So, if you see the terms that are adjacent to it, you can clearly see the second part, third part is the derivative of the power of the first part. So, what I mean to say here, it is integral of 5 power x is there. Correct, no? Now, let us take this. 5 power x dash. Let me write that. Just see that. What is its derivative? A power x derivative. A power x into log a. This is there. A power x into log a. Log a means log 5. Into its derivative. That is 5 power x into log 5. Into its derivative. 5 power x into log 5. So, how many log 5s are missing here? Just you have to multiply and divide with that one. So let us see this again. This is a 5 power 5 power 5 power x. I wrote it as 5 power 5 power 5 power x dash. Now, what is derivative of a power x? A power x into log a. Not done. Again, this is considered as x and hence we have to write its derivative also 5 power 5 power x into log a into its derivative again 5 power x into ln 5. So, what is that you have to understand? This is also containing in this derivative only. So, it is not this. It is not this, but it is simply 5 power 5 power 5 power x dash dx. And how many log 5s are missing here? 1, 2, 3. So they will be extra there. So write it as ln 5 whole cube. ln 5 whole cube. Just see that. So you have to think faster. You have to think faster whenever you have learnt already the differentiation. Because anti-differentiation is nothing but integration. So there is every link between that and this. That's what I did. Now integral and derivative. Integral and derivative. Inverses. Inverse like f inverse of f. Sine inverse of sine. Like that, it is derivative and integral cancels. The answer is 5 power 5 power 5 power x divided by ln 5 whole cube plus c. Think about that. This is integral and derivative are anti, that gets cancelled. Going to the next one. It is denominator is containing tan x and numerator is containing secant square x. Secant square x is nothing but the derivative of tan x. So what I'm doing, I'm writing the numerator. I'm writing the numerator like this. 2 plus tan x minus of 1 plus tan x whole divided by 1 plus tan x into 2 plus tan x into derivative of tan x. What is that I need? You have to understand carefully. Instead of x, you have tan x here. That's it. Instead of x, you have tan x here. So, you can treat that as x and you can integrate. That's what I'm saying. You can treat that as x and you can integrate. Now, if you split it now, these two getting cancelled. What is that remaining? Integral of derivative of tan x upon 1 plus tan x minus derivative of tan x upon 2 plus tan x. Just to see the beauty of this problem here. It is, of course, I'm not writing anything here. It is f dash x by fx. F dash x by fx. So, f dash x by fx is ln mod of fx. 3 mod 3 minus ln mod of 2 plus tan x. So, final answer ln mod of 1 plus tan x upon 2 plus tan x plus c. That's it. Done. Just to see the adjustment here. If you get that adjustment into idea, the integration goes very easy for you. So it is nothing but the function is there, and inside function derivative is there. Inside function derivative is there. That's what it is. Now the third one is little difficult to understand, but you have to follow. That is integral of x root 1 minus x square. I'm erasing this. Integral of x root 1 minus x square divided by 1 plus x square. The x root 1 minus x square divided by 1 plus x square dx is the given integral. Now what I'm doing, I'm adjusting it, just a moment. This is integral of root over 1 minus x square divided by 1 plus x square into derivative of x square, I write and I write 1 by 2 outside. See the adjustment there. Derivative of x square is 2x. So that is 1 by 2 I have written out. Now you have to treat this. You have to treat this x square as x, please. You have to treat this x square as x. We did a previous problem in the previous video. Integral root over 1 minus x by 1 plus x. Integral root over 1 minus x by 1 plus x. We did that in the previous video. So this is nothing but half integral of, if you eliminate the root in the numerator, it is 1 minus x square divided by root over 1 minus x power 4 d of x square. Don't say this as x power 4. This is nothing but x square only. X square whole square. X square whole square. So 1 upon root over 1 minus x square. 1 upon root over 1 minus x square. Sine inverse. Sine inverse x square. The first part is done. Minus x square upon 1 minus x power 4 under root. Treat that x square as x only. Here x power 4 as x square. What is the derivative of x square? 2x. I must have 2x in the numerator. Minus 2x in the numerator. Minus 2x. So what I'm doing, plus 1 by 2 into integral of derivative of x square. That is, I'm writing 1 minus x power 4 divided by under root 1 minus x power 4. Just see that. This is finished here. This becomes 1 by 4 here because one more 1 by 2 is there. I multiplied with 2 and divided with 2. And it is derivative of x square. So half sine inverse x square plus 1 by 4. 1 by 4. It is f dash x by root of x. F dash x by root of x. It is 1 by 4 into 2 root 1 minus x power 4 plus c. Done. This is a little difficult to understand. If you really understand this, you take it as granted, you understand this principle. Now, the next one is easy to understand. Next one is log of x plus 1 minus log x. Log of x plus 1 minus log x by x into x plus 1. It is simple problem. Like log of x plus 1 minus log x into, what is the derivative of log of x plus 1? 1 by x plus 1. What is the derivative of log x? 1 by x dx. Take LCM here. X into x plus 1, which is there. Just see that. X into x plus 1 in the denominator. If you say this, x minus x minus 1. X minus x minus 1. Minus 1 remains. So put a minus out. Put a minus out. Now, this is in the form of fx power n into f dash x. Fx power n into f dash. I wrote its derivative here. So, this is simply minus fx power n into f dash x. Fx power n plus 1. 1 plus 1. By 1 plus 1. That's it. This is the answer for this. Minus 1 by 2 log of x plus 1 minus log x whole square divided by 2 minus half of log of x plus 1 minus log x whole square plus c. Just see that. See the comfort there. I wrote the answer within one step. If you follow this carefully, the integration goes very easy for you. You have to think in this direction. If you think in this direction only, your ideas will be, you can get more and more ideas to simplify the problems. Let us see the next one. Integral root over cos x minus cos cube x whole divided by root over 1 minus cos cube x. What I am doing, as far as this is the fourth video I am doing, so far I have not applied any substitution. I am trying to avoid substitution. So it may not be possible for all the problems, but as far as possible, if you think if you solve the integral problems without substitution, take it as granted, you are doing well. You are doing well. So if you see the numerator there, integral of, what I'm doing, I'm taking cos x common. If I take cos x common within the brackets, I'll get 1 minus cos square x under root, which is nothing but sin square x. Sin square x is nothing but under root sin square x is nothing but mod sin x. Mod sin x. He did not mention anything about whether sin x is positive or negative. He did not mention anything about that. So I took mod sin x, but we will take it as positive only. Divided by root over 1 minus cos x whole power 3 by 2 whole square. Just to see that, please. Just to see that, what is the adjustment I did? Root cos x mod sin x, I have got it from the numerator. And denominator is root over 1 minus cos x power 3 by 2 whole square I wrote. Now what I'm doing, I'm just thinking, what is its derivative? What is its derivative? 3 by 2 into cos x whole power 3 by 2 minus 1 is 1 by 2. That is 3 by 2 root cos x into cos x derivative minus sin x. Cos x derivative is minus sin x. So what is that can be written here? What is that can be written here? 1 upon root over 1 minus cos x whole power 3 by 2 whole square into derivative of cos x whole power 3 by 2. I wrote it just to see the adjustment now. I wrote it forcibly. This is 3 by 2 root cos x. 3 by 2 is not there. So I wrote 2 by 3 out. Into cos x, root cos x is there. Into cos x derivative minus sin x. Minus is not there. I am putting minus there. We are taking sin x greater than 0 here. Otherwise, there are chances of getting two answers. One for plus, one for minus. But for this problem, we are taking positive only. Now, it has come to the form of integral 1 upon root over 1 minus x square. 1 upon root over 1 minus x. This is nothing but x only. Integral 1 upon root over 1 minus x square into dx is nothing but sine inverse cos of 3 by 2x plus c. That's it. Done. See how many steps I wrote. So you have to think in that way to solve the integration problems easily. Coming to the next one. It is still simple. Still simple. See that one. Integral of x power minus 3 is there. 5 power 1 by x square is there. 5 power 1 by x square, what I am doing, I am writing it as derivative of 1 by x square. What is derivative of 1 by x square? Minus 2 by x cube. Minus 2 by x cube. 1 by x cube is there in the problem. 1 by x cube is there in the problem. So, minus 2 by x cube. So, minus 2 missing. I wrote minus 2 out. Minus 2 out. Now it is simply 1 by x square here, 1 by x square here. It is in the form of 5 power x dx. 5 power x dx. Anti-differentiation formula, integral a power x by log a. So it is nothing but minus 1 by 2 into 5 power 1 by x square divided by ln 5 plus c. That's it. Just understand it is inside derivative out. That is why I name it as inside derivative out. So follow this carefully. Many problems like this can be solved easily. I have not taken many. And in the next session, in the next video, we are going to solve the integrals of fractions using the method of partial fractions. But before that, I'm going to give you really a short form. I cannot say these are short forms, but I classified them to easy methods I classified them to easy methods. Giving shortcuts means giving an extra formula to you and asking you to remember that formula besides all these formulae. I don't like it. That is why I classified those problems into easy methods like this to avoid substitution. So partial fractions, I'll give you a short form first. So I'll make a video how to find out partial fractions easily within 1 or 2 steps. And then we will proceed on to the integrals, finding the integrals using the partial fractions. See you in the next video. Namaste.